I am going to talk about parsers is actually that project you mentioned. I had to write a parser for a quantum computer specific language that wasn't ready when we started working on the project. So we had to build the parser while we were working on the project. And that sounds like a very daunting task. Yeah, it was. But I'm going to make sure that it doesn't feel as daunting for anyone who wants to try it out for themselves by walking you through a simpler program. What we're going to do is create a application, or yeah, okay, I'll let you in on a secret. I already created the application, but I'm going to explain what steps are needed to do so. To parse a string of text into a string of text into a data structure, and then we can get a value out of it. And the data structure is probably something you all have encountered before when you're working in Jira. You have the logging hours that you can write, for instance, 3 weeks, 4 days, and 12 hours. Can everyone see my screen? Well, I guess people do. Okay.
Yeah, we do.
Yeah. Okay. Great. So you probably recognize the 3W, 4D, 12H, and that is the way you would write or you would log work on Jira. And as soon as you put it in, it will convert it into a canonical unit of time. For instance, 12 minutes or something. And that's what you want to do. And we're going to do that by creating a parser. So that brings me to the first point. What is a parser? A parser converts input, which is often text, into a data structure. And it does so by feeding a random string into a lexer first. That will create a list of elements that it will find. And that will be interpreted by a grammar that will create a parse that will be combined into a parser, and that parser will output a multi-dimensional array of items that will correspond to the structure of that text. So at the end, we'll have a value out of it. And I can already show you that index.json, JS, and it's 3 weeks, 4 days, 12 hours, and it will log 12,720 minutes. And of course, I can write something else. This is less, or 3 weeks. So first step is a lexer. A lexer is a application of sorts to tokenize that input. As I explained, we'll take that, again, 3 weeks, 4 days, and 12 hours. And we have to explain the what all these different characters mean. So what we see is we have a 3, and that is a value. We have a W, and that is actually a unit of time. Then we have a space. Yeah, that's just random white space. But we have to explain that white space is something that we can either ignore or not. And then we have a 4 again, a value, then a D, again a unit, then another space, and then the 12. That will be 2 characters, and that is also a value, and then again an H as a unit. So what we then want to do, and I'm gonna get that part over here, we're going to write these regular expressions to actually define these parts of our string. So a white space is a white space characters are either a space or a top. A number, yeah, it could also be a float, so that's why I wrote this longer regular expression. So it's either an integer or possibly a float, so there's a point in there. And then we have these units, and these are keywords. So these are special. I'm not going to explain why. That's maybe for a later moment. But here I explain that if you find anything of value A through Z once or more, and they fall into the category of M, H, D, or W, they are keywords meaning minute, hour, day, or week. I'm going to compile that into a lecture and export that. And that is the input for the next step, but I'm first going to show you what happens if I'm actually running that lecture. So here, I'm going to feed it to my lecture. So if I now run it, first save it, of course. Then you can see I now have a list of values, and these are the so-called tokens of my language. So I described pieces of text that have a specific meaning, and this meaning is the type that I defined in my lecture. So here I see number. Value 3 is a number, and it is found as text in my input string. If I would say 3.3 weeks, for instance, I get a number of 3.3 in there. And then the next token it finds is a week. If I would write 3.3 weeks and 4 days, you then see there's these WS for white space character, and that's here. So now we have an idea of what words we can use in our language, but now we have to describe the grammar of our language. So that the grammar is actually describing what the sequence is of these values. Again, 3 weeks, 4 days, 12 hours. We already said we have a number, a unit, a white space. Well, I can go on and on, but I'm gonna take it step by step. So this thing I'm gonna call a statement, and that statement consists of a quantity of time with maybe a white space, and then I see another quantity, another potential white space, and then I see another quantity. So now I specified that these white space characters are optional. This would be, in my opinion, the same as this. Of course, I might add 1 minute after this. So we can actually say a statement consists of a quantity and optional white space, and that is one or more times. And then I can go to quantity is a number and a unit. And then I can describe, well, what is a number? A number is one of those tokens I talked about, number. And this means I'm referring to the token from the lecture. And a unit would be either a week or a day or an hour or a minute. And now we already have my whole grammar written out, because this is what I wrote. And you can see that this doesn't really look like JavaScript, it doesn't. It will compile to JavaScript, and this is actually the Nearly where Nearly comes in. This is the Nearly will convert this grammar.ne for Nearly into a JavaScript file. So I prepared some scripts to make it easier. I'm going to run the Nearly compile script. So npm run Nearly compile. It outputted a new grammar.js. Grammar.js. So the output would be this. And you can already see that this is also what I put in here. So it's combining JavaScript that I wrote here with the how do you call it? The compiled Nearly grammar. And let's see, where was I? Let's show what that output would be. I'm gonna exclude the lecture because now we want to see what the output would be of the parser. And now you see that we have a multi-dimensional array. You have all these arrays inside arrays inside arrays. And this nesting actually corresponds with the grammar that we wrote. So going back to the readme.js the markdown, this is the parse tree that we get. So we run to the text through that parser, and it will give an array of parse trees. Again, I'm not going to go into why it's an array of parse trees, but the first one will look like this. So we have an array for the rule of the statement, and all the things that were captured in that statement will be elements inside that array. So we have that capture group within the brackets. Then we have the quantity and a white space, and of course the quantity will then give a number and a unit, etc., etc. So now we have something that we can actually work with. We have that parse tree, and the nice thing is that we can now also with these values we can also show errors in there. That you say you have an error on line 1 at point 3 if you're using a wrong statement. These are all things that you get by using a parser, but of course we're now interested in actually getting to that structure. So what I did is get that parser result. So I get the first parse tree as a result. I'm going to flatten it. I'm going to strip out all the white space characters. And then if I don't have a number, that means I have a token that describes the unit. So I'm going to use that unit. So I'm going to make an object that collects all these things. I'm going to write that here, reduced. So I get all these values combined. So I have 3.3 weeks and 4 days. And then I can use that reduced object. I can put it into this function to make sure I get a total. And it will be my canonical output in minutes. So that's it. I hope you now kind of get an idea of how to write a parser with all the steps involved. If you don't worry, you can hit me up on Slack. You can also go to GitHub, to my GitHub, and take a look at the project. I made it public, so you can just view it if you want.